working together since about 1991 or 92, and I'm an independent structural expert in fiberglass engineering. Primarily, I'm a naval architect and boat and ship designer, but you know, we did it first. Anybody else who wants to build anything in fiberglass, like Disney, Universal Studios, Cinnabar, the theme parks, SeaWorld, they call us, and we'll work with their engineers to design whatever it is in fiberglass, make it fire retardant if it's necessary for their application. And how many have worked with fiberglass before as a laminator, repairer? Okay, so we're going to sort of start from scratch, and I hope I don't bore anybody who's been in this business for a long time. But let's talk about the materials itself and why San Juan Pools is made the way they are, and why the competitors think they're doing something that is different. We'll show you why it's a bad idea, but Kirk's been around probably longer than any of them, and consequently he knows what he's doing. Okay, what are glass fibers? Glass fibers have about 6 times the strength of structural steel in tension. For the same cross-sectional area, that may open some eyes here, but it's very flexible stuff. Structural steel is stiff. Fiberglass is almost like rubber, but boy, is it strong.
When you hand lay a pool, it's kind of like making a suit. You have to have a template, and you have to have a pattern, and you have to cut out your materials. So the difference between making a suit and making a poncho is it takes a lot more labor. Right? You take a poncho, you cut a hole in a piece of fabric, you put it over your head, poncho. You say, no, I want a tailored suit. You actually have to have a pattern, you have to cut out the fabric, you have to sew it together, you have to join it, make sure all the layout is correct. And that's the difference between a hand-laid pool and a sprayed-on or chopped pool, is how it's constructed. So for every model pool, we have a cut book. And that cut book tells the people how the layers of glass are going to get laid out for the pool. There's 2 types of pool fiberglass. One is called chop strand mat. So here's a roll of it. And this material is made on a conveyor belt, and it's chopped up little pieces of fiberglass. They come down a conveyor belt, they're sprayed with a binder, they're pressed flat, and then they're rolled up. The benefit of this is that you can handle the material.
You've been through the shop, you see how they hand lay their fiberglass, and they use a lot of woven roving. Most of the industry uses a chopper gun for tubs and showers and really cheap boats. We don't build big boats with a chopper gun anymore. In fact, we don't build too many small boats with chopper guns. But this is all hand-laid fiberglass. There are a bunch of reasons why you want to use hand-laid material rather than a chopper gun material. And let me say first, the lowest grade form of fiberglass known to man comes out of a chopper gun. It does compare the matte woven roving laminate that San Juan Pools builds their pools with an all chopper gun laminate. Now, brushing aside the idea that a chopper gun operator can make it lumpy, and whether it's thick or thin, who knows, what is he giving you, I don't know, but you need a very predictable thickness to get any kind of constant structural properties, and the hand-laid material will give you that, whereas the chopper operator is entirely, the laminate is entirely operated on this, predicated on the skills of the chopper operator. If he's really good, he might be able to do a good job, but nothing is better than the Owens Corning's, PPG's, FTI's, and other fiberglass suppliers who make their chop strand mat, for instance, which is the same material on a conveyor belt, and their chopper operator is a machine, and it does things very, very predictably, and you will get a consistent thickness, unlike the operator in the shop. But there's a reason why we pay that extra money for the more expensive material. But if you're going to build something cheap, a creel of roving through a chopper gun. This is called gun roving. Is pretty cheap stuff, and it's the least expensive way to build a fiberglass part if you don't care about structural properties.
So this material is put down, and we put down 2 layers of it. It's put down against the gel coat, and it helps support the gel coat material. So while the gel coat is curing out, 1 layer of this is rolled into it, and that then gives structural support to the gel coat. Next thing we do is we come back and we put 1 layer of the mat, 1 layer of the woven roving, 1 layer of the mat, and 1 layer of the woven roving. And those 5 layers represent the physical laminate of the pool shell. If you look at the material, the fiberglass, this mat material, you can kind of pull it apart, and it's only about 1 inch, 1.5 inches long. And you can pull it apart until you get a single fiber, and that fiber structurally is only bridging a small area. If you look at the woven roving, it's actually strands, and those strands are gathered together and woven into a pattern. So a woven pattern is much stronger than just a flat laid up. The other thing is that the fiberglass itself, if you notice, it's made out of strands, and I can kind of work them apart. And those strands individually represent 1 tiny little hair. So you can see there's 1 hair that I've lifted apart, but that hair runs the entire length. All of these hairs run the entire length. So when you're pulling on the shallow end of the pool, you're pulling on the deep end of the pool because they're all connected. If you take a look at it, can you help me out here? See if you can pull those apart and then snap one. Break that one. Yeah, now make it thinner. Grab that tiny little hair one. Right, pull it apart till you get to the smallest layer. There you go. Now break that one. So you broke it in half. So the value, the strength is in numbers. If you just have 1 tiny little thread, that thread can be broken. If you bundle them together into larger threads, they become stronger. And then if you weave them together, they build the ultimate strength. And that's really where the strength comes in a hand-laid pool, because it's not chopped up fibers that pull apart.
Anyway, here's a structural laminate comparison. I may jump back to this slide from time to time during the presentation, but on the left we have a property called stiffness. Now in a competitor's advertising, I noticed they made a big deal about stiffness, saying that chop is stiffer than woven roving laminates. That's a lie. I'm sorry, that's totally wrong. I don't know where they got that idea from. But woven roving gives you the highest, for the cost, it's one of the best materials you can buy in the fiberglass industry. And way back in the early 80s, we built a bunch of fiberglass mine hunters for the US Navy. And we did explosion testing and impact testing, and we also rewrote the Navy's fiberglass repair manual back then when I worked in Washington. And we found that alternating plies of mat and woven roving give you the highest impact strength of any fiberglass known to man.
Okay, did it go through?
No. It hardly broke the gel coat.
Flexural strength. Well, that's important if you install a pool where you have a void under it. Let's say you've got a gap in the gravel and the ground under it, and it's got to bridge that gap. The pressure of the water bears down on it, and flexural strength of laminate is important in that situation. It's not just a membrane. It's got to be able to survive some bending. And if there's a void underneath, you're going to need some considerable flex strength.
Have go up a little further. There you go. So as you can see, the whole weight of that 58,000 is pressing down San Juan fiberglass pool.
This is comparing the same amounts. Tensile strength. Well, as you know from the vinyl pool liner business, tensile strength is pretty important. You know, a geomembrane. And the fiberglass is asked to be a geomembrane of sorts to keep the water in.
Onto a 27 mil liner. Now this is the deluxe liner, and again we have a piece of a San Juan fiberglass pool, and we have liquid nitrogen at minus 320 degrees below zero. So as we pour the liquid nitrogen into the cooler, all right, so that's now minus 320 inside there. And show me the vinyl liner, how it bends when it's at room temperature. And today it's about 60 degrees. So you can see nice and pliable. And then the San Juan stir stick, make sure it gets in there. So here we have 27 mil vinyl liner, minus 320 degrees. We also have the San Juan fiberglass pool submerged in the same liquid nitrogen at minus 320 degrees. So what happens to the thicker vinyl liner pool after it gets cold? Wow, that stuff just exploded. And again, the San Juan pool, what happens to the San Juan pool? Why don't you hit that with a hammer? How about a bigger hammer? No damage to San Juan pools, minus 320 degrees. San Juan, the world's strongest pool.
Just the opposite of what we do in the marine industry. We want to keep the water out. But tensile strength is the most important property for the fiberglass laminate to keep the water in. And as you can see, the alternating plies of matte and woven roving are considerably superior to the all chop laminate.
This is the strength test. We have the fiberglass woven roving acting as a shackle. The pool and the spa have 2 layers of this hand-laid woven roving. That's where it generates its strength from. We've used it as a shackle to tie the 2 together, and we're using it to pick up this spa. Go ahead, Gary. There you go. So you can see the spa is completely off the ground, and it's being carried only by the woven roving strands. That means the product that it's made out of is strong enough to carry the entire load of all the weight of the resin, the chains, and the tires. San Juan fiberglass pools, building the strongest fiberglass pools in the world.
All right. Hey. You know it.
All right, go down. All right, so if you have any questions, you can come back to the room. Anybody want to inspect the woven roving, they can see that it's identical that we just pulled out of the fiberglass.
Good job, team! Good job, team!
Oh, there are marshmallows everywhere.
Okay, here we have a cutout from a San Juan fiberglass pool. We have a 1/4-inch thick plate bar, and we have 3,000 degree acetylene cutting torch. So first we're going to apply some All right, let's see what happens when you apply that to a San Juan pool. All right, and then what happens when you, no damage to the San Juan pool, as you can see. What happens when you do that to the steel bar?
Fire coming out.